Hello everyone, today we will take a look at the working principle of the thermal electric infrared sensor and its basic application circuit. The thermal electric infrared sensor does not actively emit infrared rays, but uses the infrared rays emitted by the object itself to achieve detection and control purposes. We know that all objects with temperature emit infrared rays, and each object emits infrared rays. Infrared rays have different wavelengths. For example, the infrared rays emitted by the human body have a wavelength of about 9 to 10 nanometers. There are some filters and filtering circuits inside the thermal electric infrared sensor to filter out clutter other than the infrared rays of the specific wavelength of the human body. Therefore, its sensitivity to the infrared rays emitted by the human body is relatively high. In many natural sensors, this kind of infrared sensor will be seen in automatic control circuits. For example, automatic control circuits, automatic control of corridor lights, automatic control of doors, etc. will all see this kind of sensor. First, let's briefly understand the working principle of the thermal electric infrared sensor. In this circuit, the 8th leftmost one is the probe of the thermal electric infrared sensor. Behind it, these circuit sit is some amplification and control part of the circuit. Let's first understand its working principle. Its interior is mainly composed of the thermal electric effect crystal and the primary filter amplification circuit. So first of all, what is the thermal electric effect? The thermal electric effect is a certain kind of crystal. When its ambient temperature changes, the charge inside it movement will occur through the subsequent amplification circuit, which will convert this movement of charge into a voltage output. Inside the sensor, there are usually two crystals with this kind of thermal electric effect, which are connected in series and parallel. When the external object is stationary or the background infrared radiation enters, the thermal electric effect of these two crystals will be opposite. They cancel each other out, so the change in the voltage signal it outputs at this time is relatively weak. When the external object moves, the thermal electric effect of the crystal of the internal thermal electric infrared sensor will not cancel each other out, so the change in the voltage signal it sends out at this time will be relatively strong. Because it has a filter inside the circuit of light and filtering, so its output signal strength will be relatively large when the human body moves. If you want to know more about the circuit, please pay attention to my channel. Thank you everyone. So in the working garden of this infrared sensor probe, there is an article on my homepage as an introduction. If you are interested, you can search it. So there is already a part in this sensor. The front stage is amplified, that is to say, its induction signal has been amplified by the FIRST stage and changed into a voltage output through the amplification of the field response tube. However, its signal output is relatively weak and there will be some clutter entering, so it cannot directly control the load. Then the subsequent circuit will control the infrared sensor. The signal output by the sensor is further amplified and filtered, and then some delay and other control circuits are added to achieve the purpose of driving the load. There is a chip U3 in this circuit. Its model is BIS 0001. This is a dedicated chip mainly used to control the function of the thermal test electric infrared sensor. So today let's focus on the working principle of BIS 0001. The inside of this chip is mainly composed of 4 parts: a high-impedance operational amplifier, a bidirectional key amplifier, and an output control delay. The operational amplifier preamplifies the signal output by the thermal test electric infrared sensor. What is the function of the key amplifier? It is used to filter out some useless signals, which will interfere with the input signal and improve the anti-interference ability. There are also timers for output delay and blocking time. These two timers are used to control the output delay. Let's briefly understand its working principle through its internal structural framework. This part is BIS 0001. The two on the far left in the internal structure diagram are the operational amplifiers, and the two here are key amplifiers. Of course, there is a third key amplifier, a total of 3 key amplifiers, then the rightmost state controller and 2 delay control circuits. The signal of the infrared sensor is initially amplified through these two operational amplifiers, usually through the first OP01 OP1. Then its signal will pass through this 16 pin, which is the first amplified output pin of the first operational amplifier. After the output, it will enter the second operational amplifier. Then the signal amplified by the second operational amplifier will pass through the 2 subsequent key amplifiers for key amplitude. Two-way key amplitude will be used for key amplitude. The useless internal structure op-amp will be put in, and then used. Some clutter signals are filtered to further improve the anti-interference ability. There is a COP3 third key amplifier below. It has a pin 9 VC as an external pin. Its function is equivalent to the enable terminal of the chip. When the enable terminal is connected to a low battery, the subsequent circuit will not work because in this enable terminal some environmental control circuits can be connected to the outside of the terminal, such as photosensitive resistors to detect the intensity of light in this environment. If it needs to be controlled during the day or night, for example, the induction light in the corridor can be added to this circuit. When the light is strong enough during the day, this circuit is ineffective. It also means that when the human body passes by, it does not output to the outside. When the environment temperature, this chip will only work when the ambient light intensity is relatively dark. So what is its internal working principle? We only do a simple understanding of it. Mainly, let's take a look at the working principle of its external circuit. In this circuit, the output of the thermal radio infrared sensor at the front is pin 2, so it passes 1,41,516. These 3 pins are the first operational amplifier. After passing through the first operational amplifier, its signal output terminal 16 pin passes through the 5 sum of the resistor and capacitor and then enters the second operational amplifier for amplification. Then the output of the second operational amplifier is internally connected to the bidirectional voltage converter. So after passing through the voltage converter, its signal will pass through the logic control part and the delay part. Pin 9 here is the enable terminal just now. A resistor is connected to this side and a photoresistor is connected below. When the light intensity is strong enough during the day, the resistance of the photoresistor is relatively low. So at this time, the battery of pin 9 is a low battery, and the circuit behind it is not. Similarly, it does not work. When the light is weak at night, the resistance of its resistor will become larger. At this time, pin 9 will become a high battery, and it will be controlled by the infrared sensor of the thermal test chain to achieve the purpose of output control. The circuit on the left is the peripheral circuit of these 2 parts. It is the peripheral component part of the amplification part. Then 3 on the right. What about the external circuit of the 4 pins of 456? The external resistor and capacitor of these 4 pins have a total of 2 resistors and 2 capacitors. These 2 parts are the delay control of the output. The above part is called departure time. Then its delay time is determined by these 2 resistors, 2 components, resistor 20 and capacitor C15. So its approximate time has a formula of about this result is equal to 24 times the resistance and capacitance. Then its delay is called the starting block time. Then there is a delay part composed of the two components R11 and C14 below. It is called the output delay. The output delay. So by changing the values of these two sets of capacitors and resistors, the delay time of the two circuits will be changed. What is the output control delay? What are departure blocking time and output delay? Then the above departure blocking time is equivalent to the interval between two departures, that is, after the first departure, there will be a delay in the middle of the second departure. After the delay time is up, the next departure will be enabled. In other words, if the delay time between the two times is not reached, then it is impossible to start again. That is to say, if the human body moves in front of the sensor probe at this time, it cannot be started again. The output delay B. ILO is the output delay time of each circuit. The delay it outputs after each start, then its working process is when the human body moves in front of the sensor. When the intensity reaches its starting condition, it will output first of all. Its output will be delayed through the output delay time. That is, when the human body moves, the chip will start timing. For example, if the value combination of resistor 21 and C14 reaches its output time, for example, it is 10 seconds, then it will enter the departure blockade time after starting once and reach ing 10 seconds. For example, the departure blockade time is also 10 seconds. Then when the output after 10 seconds will enter the trigger blockade of 10 seconds, when the human body moves again within this 10 seconds, it cannot be triggered again. Only when the trigger blockade time is up, the trigger delay will be entered again when the human body movement is detected again. So these two, one delay is called blocking time and the other is called output delay time. The following output delay can control the delay time of each output. For example, the corridor light needs to be on for 1 minute or 2 minutes each time. This time is controlled by these two resistor capacitor components. Usually, the delay time is controlled by adjusting the structure of this resistor. Then the above this trigger blocking delay is mainly to improve the anti-interference ability and also achieve the purpose of energy saving. When repeated movement, a blocking time will be added. Within this time, it will not be triggered to achieve the purpose of non-repeatable triggering. Pins 1 and 2 are on the bottom of the chip. Pin 1 is the external output. That is to say, the number 2 pin of its out end reaches the out end. When triggered, its battery will become a high battery. So the number 1 pin is also a logic control terminal. So its function is to enable the repeated trigger terminal. What is repeated trigger? Then this terminal can be connected to a high battery or a low battery. When connected to high battery 1, it is called repeated triggering. When it is connected to low battery 0, its repeated triggering is invalid. What is repeated triggering? If this repeated triggering is effective, when the human body moves in front of its sensor, if it can always monitor this effective movement, after monitoring the effective movement, its output will always be the high battery will only switch to low battery when the human body moves away and the output delay time expires. It cannot be triggered repeatedly. That is, when the human body moves in front of the sensor, it reaches the output delay time and then moves. It will immediately become a low battery and then enter the trigger block when triggered. After the blockade is delayed, it will be detected again, that is, there will be a logical change between repeated triggering and non-repetitive triggering, that is, the change of low battery and high battery. If it is triggered repeatedly, Then when a valid signal is detected, its battery change will remain unchanged, that is, it will always be output. If it is not repeatedly triggered, it will reach low battery. The change of the bottle is the cornerstone condition. When the cornerstone condition is reached, it will automatically first become a low battery, then enter the trigger blockade, and then detect it. There is such a process. Let's take a look at the actual sensor. This is the circuit of the thermal test sensor. The metal package in the middle part of the circuit board is the infrared of the thermal test. The part of the sensor in this direction in the mid. DLE is the window where infrared light enters. It is a filter that filters out some clutter and infrared rays of non-specific wavelengths. The surface package on the back of the circuit is the chip of U3BSS0001. Then in the middle part of the circuit board, this metal package is a thermal test infrared sensor. There are two adjustable resistors here. The adjustable resistors are used to adjust the delay. There are two pads here. The two pads here are to control the repeated triggering. Because the window in front of the infrared sensor is just a light filter. It does not have the function of condensing light, so the light incoming window of the infrared sensor means that the angle of the incoming light will become larger, so the radiation range it reduces will be larger, and its sensitivity will decrease, so a lens will be added in front of it to process the incident infrared light. In order to achieve this effect of improving sensitivity, this kind of lens is usually used in front of it. This kind of lens is called a Fresnel lens. This kind of lens will have a specific angle. There will be a specific angle in its parameters. It will converge the surrounding infrared radiation into a certain angle range to enter. This is the window of the thermal test electric infrared sensor, so its use is like this. In front of the window, a primary lens will be added to focus the infrared light. Next, let's briefly demonstrate its work. There are 3 pins on the back of it. These 3 pins correspond to the positive pole of the power supply, the negative pole of the power supply, and the output. What about the output? Since there is a green lead connected here, its working current is relatively small, so there is no additional amplification part. If you need to drive a load with a larger current or a load with a higher voltage, you need to add an amplification part, such as a 3-stage tube ELF amplification, or by driving electrical appliances to control higher voltages or current load. Here we just use an LED to demonstrate its working process. We pass the voltage to this circuit. The working voltage of the chip is in the range of 3 to 5 volts. On this PCB, there is a circuit with a DC part, so its input voltage range will become wider. What we are currently connected to is a working voltage of about 4.0 volts. So what is the delay time of its status? I adjusted the time to be relatively short, about 1 to 2 seconds, and then trigger it repeatedly. Now I use a non-repetitive trigger. When I move in front of it, you can see that the light will light up and it will automatically go through the 5-chord soft chord. Ohm's color light is good. Rainbow light continues to model respawn charm curve theta. Of course it will have a small shock. Start its crack line in the voltage and then check its variable speed. Subscription reward support in about 5 seconds, that is, when its output time is reached, it will enter the blockade time. When the blockade time is reached, it will enter the next effective start. That is to say, when the human body moves in front of it, it will first enter the blockade. After the blockade time is up, it will enter the next step of detection. Therefore, this light will not enter when you move in front. It will continue to light up, and there will be a blocking delay. In this circuit, its thermal test electric infrared sensing probe is separated from the subsequent amplification part. Now there are some circuits whose thermal test electric infrared sensing probe has been integrated with this part equivalent to this BIS 0001. In other words, its circuit structure will become relatively simple. Now the 3 pins of this sensor are the power supply. The positive power supply and the negative pole also have signal outputs. In fact, its final stage is a 3-stage equivalent to a field effect transistor. Its signal output is relatively weak. After integrating this amplification part internally, the output of this pin can directly control the load of small current. If a large current load is passed, the relay can be driven directly through this pin, so its external structure will change. It is relatively simple and its size will become smaller. Like this circuit, the infrared probe plus the decomposition point lens, plus the amplification part and the control part at the back, its size will be relatively large. If the drive part is integrated internally, its size will become smaller, which is about the diameter of this pin. Okay, today's video is here. Thank you for watching.